Hey everyone, and welcome to another explainer. Look, if you're a focused learner trying to cut through all the academic noise and just get straight to the science, well, you are in the exact right place. Today, we're tackling a massive headache in medical research, and that is establishing a rigorous, bulletproof standard operating procedure, or SOP, for measuring vitamin D in osteoarthritis research. If you've ever had a paper or a grant kicked back by reviewers complaining about your assay methods or how you define deficiency, this explainer is going to be a total game changer for you. But before we really get going, I have to give a massive, genuine thanks so much to Assistant Professor Dr. Farhad Mustafa Musa Atrushi, MD. The material we're digging into today is actually presented as a clinical lecture, directly from his authoritative research and clinical notes. His work gives us the absolute perfect blueprint for making our biomarker studies completely defensible during peer review. Okay, let's dive into this. Here's our roadmap for today. We'll cover the vitamin D dilemma, timing and sample collection, assay selection and lab rules, defining defensible cutoffs, and lastly, statistical reporting and the final protocol. Starting right off with Section 1, the vitamin D dilemma. You know, historically, osteoarthritis research on vitamin D has basically been the Wild West. It's just a ton of mixed data, conflicting trial results, and honestly, frustratingly poor reporting standards. To fix that, we have to know exactly what we're measuring. The absolute foundation of any defensible study is total 25-OHD. It's universally accepted as the primary biomarker for vitamin D status. Notice how it's explicitly defined as the sum of 25-hydroxyvitamin D3 and D2. If your study design doesn't specifically target this total, or if your lab can't distinguish between these two components, well, your data is already on really shaky ground. So, why exactly is the literature so mixed up? Well, you've got studies relying on just single measurements that totally misclassify a patient's long-term status. There are huge variations in assay quality, and some researchers just completely ignore seasonal changes. Even large datasets, like the NHANES analysis, have exposed severe cross-sectional limitations. For example, they've shown higher osteoarthritis odds at higher vitamin D levels, which strongly hints at reverse causation, probably from supplement use or residual confounding. Without standard procedures, finding the actual clinical truth is incredibly difficult. Which brings us to Section 2, timing and sample collection. To build a study that holds up to scrutiny, you have to start at the absolute beginning. We're tracing the sample's journey right from the patient's arm. This timeline perfectly illustrates a STROBE-aligned workflow. Now, strictly speaking, a patient doesn't technically have to fast just to check their 25-OHD, but if you draw blood in the morning after a fast, it harmonizes your data beautifully in case you decide to pull other inflammatory markers or lipids from that same visit. From there, you'll want to centrifuge and aliquot the serum within 2 hours. For short-term batching, pop it in at -20 degrees Celsius, and for long-term biobanking, get it straight into a -80-degree freezer. Standardized handling like this drastically reduces avoidable variations down the line. I really want to highlight this quote directly from the source material because it's absolutely crucial. Seasonality is not a minor nuisance variable. Serum 25-OHD follows a cyclical, lagged seasonal pattern. It peaks in late summer and hits its lowest point in late winter. If you fail to record the date and the season of your blood draws, you are critically undermining your entire study. Think about it. A winter sample and a summer sample from the exact same patient will look like two entirely different people. All right, moving into the laboratory domain with Section 3, assay selection and lab rules. And this brilliantly illustrates Dr. Atrushi's strict hierarchy for assay selection, because once that sample enters the lab, strict rules apply. The central issue here isn't just whether your method is called an immunoassay or whatever else, it's whether the reported result is fundamentally standardized. This table maps out exactly what is preferred for defending your work in review, what's acceptable if you're working with limited resources, and what you literally must avoid. Reviewers are going to heavily scrutinize your assay method, so let's break down the two main contenders. So on the preferred side, the absolute gold standard is a VDSP or CDC standardized LCMSMS method. Why is it so good? Because it actually quantifies D2 and D3 separately and then sums them up, which gives you incredible specificity. Now, if that's just not feasible for your lab, the acceptable alternative is a CDC VDSP certified immunoassay, but you absolutely have to verify it locally. What you must avoid at all costs for primary defensive observational studies are non-standardized ELISAs without proper calibration or external quality documentation. Just don't do it. So the crucial point here is this number, less than or equal to 5.0%. To even meet that CDC VDSCP certification, laboratories have to hit this exact mean bias target against reference methods, alongside having an imprecision coefficient of variation of less than 10%. When you're writing up your methodology, directly quoting these exact targets is a surefire way to prove to reviewers that your lab data is airtight. Let's jump over to the data analysis in Section 4, defining defensible cutoffs. This is exactly where so many researchers stumble. We literally have to abandon the idea of using arbitrary disease-specific thresholds for osteoarthritis. Instead, we should be relying on the analytic categories established by NASM, which define clear, backed-up risk brackets based on bone health. For those of you calculating at home, keep in mind that 1 nanogram per milliliter equals 2.5 nanomoles per liter. It's so vital to report these universally recognized categories rather than trying to invent your own just to fit your data. But here's the absolute golden rule. You have to analyze your data continuously first, ideally per 10 nanomoles per liter. Current endocrine society guidelines just don't establish outcome-specific thresholds for joint health. So researchers really shouldn't be making claims that hitting exactly 30 nanograms per milliliter is inherently osteoarthritis protective. These cutoffs are general status categories, guys. They aren't diagnostic truths for OA. Finally, we've reached Section 5, statistical reporting and final protocol. Okay, so we've standardized the collection, the lab assay, and our definitions. Now it's time to put all that rigorous data into a multivariable regression model. To ensure your statistical reporting is bulletproof, you have this list of non-negotiable covariants. You've got to adjust your models for age, sex, BMI, the season or the specific month of the sample, any vitamin D supplement use, physical activity levels, and yes, even the specific laboratory assay batch. Plus, if your sample size is large enough, testing for interactions between vitamin D and variables like sex and BMI is absolutely vital. Large datasets have consistently shown that associations can differ significantly across these demographics. Now, what's really interesting about this slide is how we apply everything to a specific real-world setting. Here, we see a tailored, bulletproof protocol specifically designed for Middle Eastern clinics, like those in Erbil, or, frankly, any high-sunlight setting where baseline vitamin D dynamics might look a bit different from Northern Hemisphere populations. Let's quickly summarize the actionable steps you can use right now to insulate your next grant or paper from those reviewer critiques. Step 1. Measure your serum total 25-OHD using standardized LC-MS. Step 2. Always report your primary units as nanomoles per liter and just toss the NGML in parentheses. Step 3. Run your primary analysis continuously per 10 nanomoles per liter before you ever even look at categories. And Step 4. Restrict or perfectly balance your blood draws by season. If you follow these 4 steps, you are actively answering reviewer critiques before they even write them. I'm going to leave you with this provocative thought. If a single unstandardized assay or one unrecorded seasonal change can completely derail an entire clinical study's validity, what other so-called nuisance variables might be hiding in your lab's workflow right now? It's definitely something to think about as you design your next project. Again, thanks so much to Assistant Professor Dr. Farhad Mustafa Musa Atrushi, MD, for this incredible clinical lecture, and thank you all for watching. Stay focused, standardize those practices, and I'll catch you in the next explainer.